Your Excellencies, colleagues, scientists, people who are interested in Arctic and Antarctic, ladies and gentlemen, it's my pleasure to welcome all of you to a kind of small jubileum. It's the Science Afternoon number 25 of Estonian Academy of Sciences, which is organized together with the United States Embassy in Estonia and which addresses polar research in Estonia. So basically it stresses our long-standing collaboration between, first of all, scientists, but also policymakers in Arctic and Antarctic issues. And I think that in a way this Science Afternoon will be a little bit different, and typically we discuss not only scientific issues but also societal issues of research and life on high latitudes. It is my pleasure to hand over this place for greeting words of George Kent, United States Ambassador in Estonia. You're very welcome.
Aitäh, Tarmo. Good afternoon, President Soomere, former Prime Minister, distinguished panelists, and members of the Academy and guests. It's a wonderful treat for all of us to have the opportunity to be in this architectural gem of a building designed by Martin Gropius, the uncle of the famed German-American architect Walter Gropius, the founder of the Bauhaus movement, who ended up in my family's hometown in Boston, Massachusetts. So I extend my gratitude to the Academy President for hosting the seminar here. Science and technology cooperation between the United States and Estonia is a point of pride for both countries. When I presented my credentials to President Karas upon arriving in Estonia at the beginning of the year, he spoke with real pride about the high level of co-written scientific papers. And if Estonia has the most unicorns per capita of any country in Europe, he says that it has the most co-written scientific papers with the US per capita, and I'm inclined to believe him. I'm the grandson of two science professors who maintained working relationships with international colleagues throughout their careers. And so I agree about that importance of working across borders in science to face our shared challenges. Next week, our bilateral cooperation will continue with a visit of a NASA scientist, Nicole Aunapa-Maan, who is a proud Estonian American, the only astronaut of Estonian heritage so far. And I should also say that a friend who visited here earlier this summer, astrophysicist Dr. Ben Schmidt, who installed a deep space telescope at the South Pole, is in Svalbard today, presenting at the Scientific Committee on the Antarctic Research, and he sends his regards to this gathering. Academy President Soomere has also recognized the importance of scientific collaboration through the support of the Academy's Arctic Research Professorial Program. These grants build Estonian researcher capacity to collaborate in international Arctic research, and I commend the Academy and him for that support. Since 1994, when Estonia and the United States concluded our first science and technology bilateral agreement, we have collaborated across many fields: energy, space, science education, and key for our conversation today, environmental science and marine research. Polar issues at both poles are receiving renewed and reinvigorated attention. The urgent crisis caused by climate change, as well as geopolitical currents, are driving expanded engagement. Today's panel is thus taking place at an opportune moment. We gather to hear from and learn from some of the leading experts on polar research in the United States and in Estonia. They will discuss key issues in the field, including the effects of climate change on cultural heritage, to the potential of biorobotics in Antarctica. We stand at a moment of inflection in the polar regions, as elsewhere on the globe. We see a multitude of challenges to the long-established multi-state collaboration in the polar areas. I think in the Arctic Council, Estonia is all too aware of Russia's obstructionism. And in the Antarctic, we see both Russia and China seeking to undermine established commitments to peace, science, and environmental cooperation. Just 3 months ago, Russia and China blocked the establishment of a new maritime protected area in the Antarctic. The new area would have helped protect the fragile ecosystem of the Antarctic from the effects of climate change. Now, we can't mention the polar regions without talking about climate change. There's extreme stress in both polar regions due to dramatic changes. There are regular heat waves in both poles. Temperatures reached as high as almost 40 degrees inside the Arctic Circle earlier this year, or as high as 25 degrees in the Antarctic. Heat waves cause loss of sea ice, and as the sea ice recedes, so does the irreplaceable biodiversity of polar regions. How collectively we face these challenges is critical to protecting the polar regions and preserving them for scientific cooperation. And we should come together as like-minded nations to oppose the obstructionist countries. The US is grateful for Estonia's 20-year commitment to the Antarctic as a party to the Antarctic Treaty. As climate change accelerates in the polar regions and geopolitical forces attempt to undermine such multinational cooperation based on science, we look for all like-minded countries to protect the Arctic and the Antarctic. So in this spirit, we do encourage Estonia's speedy accession to the Antarctic Treaty's protocol on environmental protection. Looking to the speakers coming up shortly, I'm very delighted to welcome Evan Bloom, whose reputation as one of our leading experts on Arctic issues precedes him. And I know a lot of colleagues back at the State Department are overflowing in their praise, Evan, of the work you've done over the years dedicated to protecting and preserving the Arctic and Antarctic for peaceful scientific cooperation. And I would thank the Estonian experts as well for putting in the years of hard work and research that educate those of us here as well as future generations and allow us to inform our policies on polar regions on well-grounded scientific facts. In that sense, we're all following in the wake of Estonian-born explorer Fabian Gottlieb von Bellinghausen, one of the first people to see the Antarctic in 1820. His voyage proved that land existed in the southern ice fields, despite previous beliefs to the contrary. And discoveries expanded our knowledge of Antarctica and set us on the path for future research and exploration. Aitäh, and after Minna-Liina speaks, we'll get to hear the real experts. And I do apologize, I have to host an event, so I will leave in the middle of the ongoing discussions, but not exactly just now.
Thank you very much, Your Excellence, also for showing excellent knowledge about Estonian history and highlights of people who have been born in Estonia, even though they haven't been Estonians technically. We still call them Estonians. So another introduction word will come from Minna-Liina, who is Undersecretary for Global Affairs at the Ministry of Foreign Affairs. Very welcome.
Thank you very much. Good afternoon, everybody. Dear President Soomere, dear Ambassador Kent, Mr. Bloom, dear guests. It is really nice to see you all here, and I feel truly humbled to speak in front of you, as was said, so many scientists and experts. And to be honest, it is my first time speaking about polar affairs and Arctic in public, so after taking up my new position in July. But seeing all of you here and having this event definitely showcases that Estonians care a lot about the Arctic, and we like to emphasize that Estonia is the northernmost non-Arctic country. This closeness can be felt. As climate change in the Arctic is progressing, its effects also manifest in our region. Be it changes in vegetation, emergence of new pathogens, or altering weather patterns. Understanding those challenges and responding to them requires cooperation. Our scientists have long-standing commitments to polar research on several topics. This gives them a stake in spearheading those global efforts. Closeness to the Arctic really boils down to human connections and scientific cooperation built on those connections. As said before, assuming my current role in July as Undersecretary for Global Affairs in the Ministry of Foreign Affairs, I was Estonia's first human rights ambassador for the 3 past years. And prior to that, a long time worked at the Estonian mission to the UN. So personally, for me, it is also a pleasure to see that so many global issues are gaining more and more traction in our foreign policy for some years now. And we have to make sure that to respond to these complex challenges, we have scientific expertise. Scientists and decision makers must talk to each other across different disciplines and institutions. I'm very thankful to Estonian Academy of Sciences for their kind cooperation in setting an example. In 2023, in cooperation with the Academy of Sciences, we again named 2 professorships for Arctic studies, further formalizing Estonia's commitment to this field. Ladies and gentlemen, the distance between us in this room and the Arctic Ocean is less than 1,200 kilometers. This is just a bit more than distance from Tallinn to Kiev. By now, more than 18 months have passed since Russia chose to brutally attack the norms underpinning our peaceful coexistence. The Russian aggression has brought disastrous consequences for people in Ukraine and also, unfortunately, globally. In research, it has rendered collaboration in some areas impossible. Arctic research is no exception. We know that nature and the environment do not change in line with national borders, but neither can our principles. A future where genuine engagement with the aggressor country would again be possible is not in sight. Therefore, to rise to the imminent tasks ahead of us, collaboration must be reinforced among partners who value the core principles of international cooperation. Here, I would like to commend the US's diplomatic commitment to anchor the rules-based order on a firmer ground in both northern and southern poles, as well as your outstanding investment into polar sciences. I believe that enhanced partnerships between the US and Estonian polar sciences can offer new openings for collaboration. I wish you a very fruitful discussion, and thank you so much for inviting me here. Thank you.
Thank you very much, Mrs. Lind. And just I have one short remark to add. The high concentration of scientists in this particular building is a feature, not a bug. And this is what just we have to live with. Also our guests, they have to live with that. And now it's my pleasure to announce basically the main speaker of today's event. This is Dr. Ivan Blum, who is Senior Fellow at the Wilson Center's Polar Institute, and you're very welcome to share your experience and thoughts with us.
So, Mr. President, Madam Undersecretary, Ambassador, it's a real honor and a privilege to be here today. Not just because this is a magnificent room, but I hadn't realized the connection to Gropius. I was born in Boston, and my father went to the Harvard School of Design, so I grew up hearing lots about Gropius in my childhood, and this connection is quite special and interesting for me. In any event, it is such a pleasure to be here. This is my first visit to Estonia. I long wanted to come here, and it's a very special first trip. And I've had the chance to meet with any number now of scientists and policymakers and members of the government, And I have been so impressed with the level of experience and level of expertise and interest in the polar regions. It's really a great pleasure to be here. So during my career as a diplomat, I had the opportunity to spend a considerable amount of time on polar issues. And I came from for the part of the State Department. We move around during a career in the State Department, but I spent most of my years as part of a bureau that supports scientific endeavors internationally and works on international cooperation among science and scientific institutions. Polar science has been a key focus of U.S. interests for a very long time, and to find those sort of interests echoed here is a very special thing. I'd like to talk about polar science, not just Arctic and Antarctic science, because there are so many connections and similarities between the two. In a world where governments have woken up to the immense crisis we face regarding global warming, it is the work of scientists at both poles that leads the way in trying to understand the phenomenon and lead us to solutions. So research at the poles is a priority, and it receives a significant amount of funding by many governments, including that of the U.S. government. And there's considerable diplomacy involved in advancing polar science, and I've been pleased to be part of that. So key is promoting science and finding ways for states to cooperate on research. International cooperation for science at the poles is quite important. As I mentioned, polar science is of rising importance given climate change, and major science programs are active at both poles. And it's not necessary for a country to have its own facilities. Its scientists can work at facilities set up by other countries and take advantage of logistics networks in both the Arctic and the Antarctic. Now, despite numerous political difficulties, both global in reach and regional, science at the poles continues to be something promoted by and important to most, if not all, countries. It's also a place where states from outside each region can get involved and make major contributions. We find this with respect to the non-Arctic states, some of whom are observers in the Arctic Council or participants in major scientific undertakings, for example, the German-led Mosaic expedition. We also find that many states are involved in Antarctic science, not just countries that claim territory there or traditional science powers. Now, in the Arctic, science is at the heart of regional diplomacy. The key value of the Arctic Council, the main diplomatic body in the region, involves the efforts of its working groups, which rely on scientific expertise. Now, the Russian invasion of Ukraine has had a major impact on Arctic cooperation, and the Council is not fully functional. Some initial steps have been taken to see if the working groups can begin some of their work again, including with Russia, and a fair amount of progress is being made under the wise chairship of the Norwegian government at this time. But there's still difficulties in moving forward in the Arctic Council. I co-chaired the task force that gave rise to the Treaty on Arctic Science Cooperation, which was agreed and entered into force, but that agreement isn't really functioning right now. For the US, its major value involved the connection with Russia, and that really isn't, that connection isn't working right now. The agreement reflected, however, the aspiration of all the Arctic states to improve science cooperation, which was a joint objective at the time. Also want to mention fisheries-related international science cooperation, which is going forward under the Central Arctic Ocean Fisheries Agreement, a 10-party agreement that includes the EU, includes the US, Russia, China, and that agreement is functioning, and science is at the core of that agreement because it's looking at trying to ensure that if fishing occurs in the Central Arctic Ocean in the future, doesn't now, that it would happen only on the basis of sound science. Now, contacts between Western and Russian science institutions have largely stopped, and state-funded projects have similarly stopped. That limits the ability to work on pan-Arctic projects related to permafrost, black carbon, environmental monitoring, etc. So, many challenges for the Arctic. Turning to Antarctica, the situation is a bit different. National programs tend to be relatively independent, and it's possible for the Russians, US, and Chinese, for example, to pursue their science goals without relying on each other. So you'll recall that the Antarctic Treaty sets aside Antarctica for peace and science. The whole point of diplomacy and governance in Antarctica relates to science. Thus, this involves many types of science. These days, there's a pronounced climate focus, but also biology, marine science, space and astrophysics, fisheries science, etc. Now, the Scientific Committee for Antarctic Research, it's already been mentioned, provides critical support and advice to the Antarctic Treaty System. And indeed, SCAR, the organization, predates the Antarctic Treaty. Now, the COVID situation has had a major impact on the operations of national Antarctic science programs, and we've seen that continuing even now and will be the case for the coming couple of seasons at least. But still, the science work being done in Antarctica remains a priority for not only the US, but the world community. Governments are supporting science at the poles. Science cooperation at the poles involves major funding and attention by numerous governments, and that support is long-term. And I think that makes it a good area for US and Estonia for cooperation in this area in the future. So the EU, just to a few final points, the EU is paying greater attention to polar science, and Estonia can play an important role in that context, certainly. Estonia can also reach out to the US and individual governments, and if and when the Arctic Council returns, further efforts can be made to obtain observer status. Estonian scientists, including early career scientists, can find ways to work at polar science through US, European, and other programs. And I think that way forward is definitely available. So in any event, thank you very much for inviting me to be here, and I look forward to the further discussion.
Thanks a lot for this information and messages. We shall have a lot of opportunities to have questions during the panel discussion, and the questions can also be nasty questions in this hall, but not accusing questions. So next we shall have overview about climate change and cultural heritages in Antarctica by Dr. Kati Lindström, who is a fellow at the University of Tallinn. Very welcome.
Good afternoon, dear President Soomere, dear, we lost our ambassador, dear Dr. Bloom. It's an honor to be here and to start off this round of presentations, given also that I am the person with the softest, not real science, not mentioned in these talks. I come from humanities and social sciences perspective, and I'm also the current Estonian contact point for the Antarctic Treaty. So I'm going to talk about climate change and cultural heritage in Antarctica, and there is a good reason, there's a reason for that, that in the last meeting in Helsinki, the Committee of Environmental Protection of the Antarctic Treaty highlighted the escalating impact of climate change as one of the top priorities to work with. And the CEP, the committee, has dedicated itself to crafting a comprehensive matrix aimed at evaluating the vulnerabilities of Antarctic heritage. And this is also a part of the climate change response work program of the treaty, and this commitment was renewed again in the Helsinki Declaration adopted at Helsinki ATCM. So the question would be, what is this about? And this is what I'm going to try to cover in the next couple of minutes. So there are currently 95 historic sites and monuments protected under the Antarctic Treaty, and the number has doubled since 1973, when there were 43 sites. And if we look closer to these sites, you will see that most of them are located at the very low coast, and particularly in the you can't see the pointer, in the Antarctic Peninsula region. And if we look now at the historical temperature change, so this is until 2006, and we know that temperature change in Antarctica is a very tricky thing. After that comes a cooling period, but we can see that between the 1957 and 26, this was the most, the area that was where the temperature was increasing most, and we can also see that this is the area that is losing most ice. So clearly these sites that are all on low-lying coastal areas are suffering from climate change severely, and I'm trying to tell you exactly how. And we should also keep in mind that there are heritage sites that are not protected under Antarctic Treaty as historic sites and monuments, and they are mostly sealing sites, and there are more than 200 sealing sites registered by archaeologists in Antarctica. Most of them are extremely low-lying, and here you will be able to see that this is the coast, right? So they are very low-lying. They had to be comfortable to go and slaughter the seals where they were. So, and they are mostly not under protection. So they are very much in danger. But I will talk you through some of the changes through this wooden hut on Snow Hill, which is historic site and monument number 38, left by the Northern Sköld's first Swedish Antarctic expedition of 1901-1903, where I've been working together with my Argentinian and Swedish colleagues with the purpose of first to document, to generate a thorough digital documentation for laser scanning, structured light scanning, drone-based orthophotography, photogrammetric triangulations, and all other digital methods to document the site, to have a reference base for a future when it's not going to be there. but also to work out an extensive maintenance works program. Argentinian Antarctic program has been carrying out an intensive maintenance program here since 1980s, but as you will see, the situation is still complicated. So one of the most obvious things that will strike you is obviously the glacier retreat. When you look at the historic photos, so this wall here, this is a glacier, right? So it's running. So there's a reason why this house stands up there on the hill. It's because it was shielded from very strong southwestern winds by this glacier. And we know that the glacier was there, more or less, in 1970s. It was even there in 1990s. Until mid-1990s, we know it was there. We don't know exactly late 1990s when the heating was really getting strong. It started to disappear, and today it has retreated several kilometers. So this obviously poses new and complicated challenges for the heritage site as such. So it's not just about disappearance of beauty, which is also part of its heritage value. So to assess the current climatic situations and to build a management plan, so we know, I mean, Antarctic climate change is a very complicated phenomenon where the locality also plays an important role. So first thing we need to know is how is the weather, how the conditions there and how they're changing. So we set up an automatic weather station which measures solar radiation, soil temperature, air temperature, relative humidity, wind speed and wind direction. So these all will help to monitor the site and plan future intervention. If we are on time, of course, if it doesn't happen too quickly, but also we can generate the historical measurement series. So we have Otto Nordenskiöld's measurement series from their 2 winters on the station, and they have obviously limited scientific value perhaps sometimes, but they have a lot of public communication value because that's something people can easily relate to. Obviously, since the glacier is gone and the glacier up in the mountains is constantly melting, there is a major water erosion from the melting water of a glacier. The risk of soil erosion was revealed during the 1993 campaign already, when the Argentine team found a major landslide here in the northeast sector of a hill. And even this year, we can say this is 2020, and this site has collapsed again in 2023. So there is a new collapse almost every year, and there was a new collapse here also this year on this site. So the hill that the house stands on keeps eroding constantly. And ever since 1993, the Argentine Antarctic authorities have tried to then enforce the hill. So they've done geological wonders, different enforcement work with thermosiphones, netting, concrete, etc., etc. Otherwise, the house wouldn't be there. But still, the changes in landscape can be extremely quick and very drastic at the same time. So in the first image, you saw a river going past the house, so it's not there anymore. It changed from one year to another and now passes a lot westwards, which we are thankful for, but at the same time, this year there emerged major pools here in between, and they needed to be emptied by hand by the crew that arrived. And what is the problem? The problem is that most of the big works in Antarctic treaty areas, they require environmental impact assessment, which is a procedure that takes a long time. But as you go there and you discover an urgent emergency situation, you need to act now or the house will not be there next year. So we definitely need within the Antarctic Treaty system a system, a regulated framework of how and when we can do emergency interventions to save these sites. It's obviously different for sites that are very in close vicinity to a station, because then they are being monitored constantly. But sites that are remote like this have a harder time. We have, of course, wind and water erosion, and I don't have a winter storm picture here, but this is a man-made storm, so to say. The hill also, what this is now being brushed off are historical remains of a magnetic measurements house and bricks. So the soil is very volatile, the snow cover is less every year, the water activity since the ice cover is less every year, the water activity on the coast is also bigger, so the erosion of waves is bigger, and we should not forget that Antarctica is a seismic place. And there are also tsunamis, both from calving icebergs and from underwater landslides, which are projected to increase year by year. So for low-lying heritage sites, again, this one wash is one too much. Since the house is on a rests on a moraine hill that is congealed by permafrost, and it also has an ice core, probably of a glacier, but we're not sure. The permafrost is thawing, and we can see that it does it unevenly. So there is a 40-centimeter difference of permafrost depth in western and eastern side of a very narrow hill. So the house is tilting, and the walls start to sag. And there's very little, I mean, we can just refill basically the mud on the slides, but this is all done by hand at this present state. So this is also very work extensive. And of course, there is a serious worry that the house will be eroded from under. So there is a melting water that runs under the moraine hill, and it can basically destabilize the whole hill from downwards, as it happens with the glaciers. But these are so we have also installed permafrost temperature measurements, and here again, I think we have a chance to recreate Northern Hill's historical measurement series. But all these climatic changes, they are compounded by burgeoning tourist activities that are again increasing year by year, partly perhaps by doomsday tourists, but generally there is a tendency of more tourists finding their way down south. Even a crew of 5 persons who goes on this very volatile moraine ground for 2 weeks, we create a lot of erosion, soil erosion. We stamp the ground, there's a lot of compacting, a lot of erosion. If you have a ship of 100 that can land in this site, they will do a lot. And if it's one ship, fine, but there might be several during the season. So the effects are cumulative, but the permits are given by ship basis. So it's very important that the Antarctic Treaty really takes the starting negotiations on tourist regulation seriously, that we get rid of the piecemeal approach that sees each tourist voyage as a separate item. And obviously tourism also increases the risk of looting. If it's bad for the HSM, it's even worse for sealing sites, which are often not even visible for untrained eyes. So a tourist group would just walk straight over, and even scientists would probably just walk straight over the historical sealing sites, which are, for most part, not properly documented. So we know very little about them. There are very little historical materials, documents about them, archival materials, because this was all business secret. So this is our only source of information, and it can be easily trampled over. And many of these sites are very close to tourist landing sites. So there is a great risk that we'll be losing this source of information pretty soon. Shifting climate conditions render Antarctic built heritage susceptible once more to different microorganisms. So we have mold emerging in different buildings that we brought them with us, and they've been dormant there all the time. So tests have to be taken. This house doesn't seem to have it yet, but some other buildings in a little bit further north have already shown signs of biodeterioration. And so the object conservation is also challenged. So we are supposed to keep all the objects down there, which is, again, easier for big sites. It's very difficult for remote sites. So you see the state of working. It's very precarious situations where you have to make sure that the objects are being safe. There's a high risk of looting, but also now that they are being attacked by active corrosion and mold and new microorganisms, it's getting more and more difficult. Again, the situation can change from one year to another very abruptly, and you can only do work with material you've taken with you. So you can't go back and buy it in the supermarket. So why should we care? So there are a couple of reasons, and I'm going to finish shortly. First, it documents the past relations to Antarctica. So there is a lot we still don't know actually about the sealing and whaling operations, for example, and this knowledge will probably be washed away before we even get it. Second, this has historically been an important stability mechanism. It doesn't help with Russian obstruction, that's true, but it is very important to keep the tension between different claimant countries in order so that each of them keep their historical sites and nobody can erase their marks from before, just in case. This is very important also for many newcomer countries to be able to say, we were here. And it makes Antarctic climate change very relatable to a wider audience who can see this destruction of human-made architecture. That's something they can relate to and they can understand, whereas speaking of different, very complicated climatic models is beyond comprehension for most. So, thank you so much, and there's also thanks to my colleagues who have worked on this.
Thank you very much, Dr. Lindström, for this, I would say, on the one hand, unexpected, and on the other hand, absolutely natural view on things. The oldest house in New Zealand is not much older than the oldest house in Antarctic. So, and I think preserving this heritage is really important. For longer history, back to even millions of years, we have basically two sources of information. They are sediments in different water bodies and ice cores. So Professor Rein Vaikmaa is welcome to talk about the achievements and perspectives of ice core science.
Good afternoon, ladies and gentlemen. There are many different fields of science which are important in polar areas. And one of the key areas is those ice cores, because a lot of climate and environmental history is actually archived in polar ice caps, especially nowadays in Greenland, in Antarctica, also smaller glaciers and smaller Arctic islands, but basically Greenland and Antarctica preserved a lot of climate history. And actually this science started, I think that maybe for most of you this is not very familiar area, so I go a little bit back and background what is behind this research. On this picture there is one of the founders of this area, Professor Willy Danskår from Copenhagen University. And I point that you can see he is holding ice core and he's smoking. He was very heavy smoker. Later on I show laboratories which are actually how nowadays people are working there, and everybody knows that you don't actually contaminate because it's a very poor water you have in ice caps. But in this time when he started, last year in Copenhagen University celebrated 100 years of birth Willy Danskår, and then they showed the movies. He was a real laboratory professor, very talented and really put base on this science. But they showed a movie when William Scott happened to be first time on field on Greenland. He has a dark costume, necktie, and walking there, and it was surprised. It is not very good, actually, close. He couldn't know how to behave on field, but he was a laboratory guy. And it was actually was early 50s when he established correlation between atmospheric temperature and isotope composition of atmospheric precipitation, composition of oxygen, hydrogen isotopes, and temperature. And this actually put basis on this field. So he organized collection of atmospheric precipitation globally, and nowadays there is a huge number of stations over the world and collecting samples, including in Estonia. We have two stations in this network. And he established this for the first time relation between isotope composition and temperature. So he got idea that if we could get ice through huge ice cap, you can actually re-establish temperature. What was the temperature in the time when these glaciers actually were formed? And there are actually three guys who put the base on the left. There is William Scott, in the middle is Chester Langway from US, and on the right, Hans Oeschger from Switzerland, from Bern University, who actually discovered that there are in ice cores, you can find also atmospheric CO2 and other gases, and establish actually to see what was the composition of the atmosphere in earlier times. And this is just a very basic. If the snow is falling, it's absolutely, at first it is not very dense, but then new layers are coming and actually it's getting denser and denser, and these blue dots there are showing that in ice there is always air. This is atmospheric air of this time when these layers are formed. And now you can actually see that if you have possibility to get samples from different layers in big ice cap, you can actually see what was climate in this time when those layers were formed. This is all the base of ice core sciences. And Chester Langway, I showed American guy, he started in early 60s to drill on northern Greenland. And there was a military base, and actually then William Scott got idea that if they are drilling there, he can get actually samples. This was a cooperation where they started and all the ice core study from this time. And in 1966, first ice core from Camp Century was drilled, and in Copenhagen lab, they measured isotope composition, and they went back to the end of last ice age, more or less, up to the 10,000 years ago. This was the first ice core actually measured. And later on, many places in Greenland, they were actually, this part of science actually got very important, and many laboratories started to work in this cooperation. And what is important to mark here is that this is very difficult, very expensive, and only basically it's clear that no one country can actually do. This is basically also only work with international cooperation. And there were new drillings also in Antarctica, then Americans drilled in Bird Station, and so on in Greenland and in Antarctica. What was interesting in middle 60s, when the Greenland, they drilled actually two ice core very close to each other. And they found that actually isotope composition is changing very rapidly, because The idea was earlier that because of basically the climate during Quaternary times have actually changed on very long times. There were actually ice sheets were growing, and this took quite a long time, and actually the main player in this is actually how Earth is traveling over the sun. And those famous Milankovitch theory shows what is causing, what is actually based on which is based climate changes. But in Greenland, they found that actually there are sometimes very rapid changes. When the cold time was ending and going for warmer, then there happened very quick and very drastic changes in temperature. And first stage, actually, people were afraid that maybe this is something in methodology, but it cannot be in such quick changes. But as later on, it was discovered that it is still possible and it is real nature it's happened. And of course, if you want to go longer in the back in time, then you have to go Antarctica, because there are thicker ice sheets, about 4 kilometers, and they started to drill in central Antarctica. At first, French groups on Dome Sea and Russians on Vostok, and this was one of the most famous ice core and studied when Russians had actually a very good drilling technique, but no laboratories. And so they find a nice way to cooperate with French colleagues, and it actually is going on up to this time. So they were drilling, and French people were actually making isotope and geochemical analysis. And there were the first actually data about how temperature was changing during last 400,000 and later on 700,000 years ago, and also CO2 and methane, and they were all in the same cycles. And so for a long time this Vostok ice core was one of the major source of information also for the international panel of climate change to get information. And there were also questions whether all climate big changes in northern part, let's say in Greenland, in Antarctica, whether they are somehow connected, or how is the situation? Do they have counterparts that changes in Antarctica and in Greenland? And here you can also see on the lower part that how rapid changes they found in Greenland. And later on they started to find such kind of marks also in lake sediments in continents, which shows that in some special times, actually climate can change very rapidly, which is really important. And it is this made people worry about we don't have to wait, let's say, 100,000 years when the next ice sheet starts, but actually all the changes can happen with very short time scale. Or still, those three guys now in the middle is Claude Loriot. He was back of all the French ice core research. He died this spring, I guess. He was much over the 90 years old. But those three are actually the most important names in this area. Of course, nowadays there are younger people and very big community working on that. And in 90s, EU started to have a joint project in EPICA, which is European Ice Core drilling in Antarctica. And this was a time when we also wanted to participate, because we had up to this time quite long tradition in ice core work in Estonia, but actually this was rather expensive for us. So our Science Foundation found that this is maybe too much for us, but I must say that ice core community is very cooperative, and when the EPICA started, we didn't actually participate personally there, but actually we were involved all the time in the discussions and meetings was discussed. And they planned then to drill 2 cores in Antarctica, one in the central Antarctica, close to Dome Sea, and other Tronic Moodland, which is coastal area and where is actually accumulation is very high. Yes, just to show how this field works in Antarctica looks like, in this time this is really a very big operation because very hard conditions there, very cold, and there was a huge team in Europe, every country put money there, and also European Community, in this time European Science Foundation. And this was a very successful project, many new information and publication. A lot of young people actually worked on their PhDs, and so a young generation was involved in this ice core science. Nowadays, actually, really, if I would go to this meeting, most of them are not familiar to me because all this younger generation has taken over now this field, but this is really nice, logical. And there are some pictures showing what they got from this Epica ice core. The upper part, this is actually insolation, which is showing these Milankovitch theories and how this is actually showing how it's reflected in ice cores in the way of temperature changes and gas changes. So you can see this is just a piece of ice core. You see, these are also how the gas inclusions are preserved. And so we have got actually information from during the last 700,000 years, how the atmospheric composition has changed, how the CO2, methane composition, how in different climate periods atmospheric gases have actually preserved. And Epica was actually one of the biggest success of EU, let's say EU countries who work together. They put together their knowledge, their efforts, every national money plus EU money. And therefore this, this is now some pictures just to show the fields there. And now you see here is the drilling, the ice core in the drill, and actually now all these drilling facilities where they collect samples, they are extremely clean. This is more or less like, let's say, in space work, so no smoking there anymore, like Willy Tanskort did in first times. And you can see here some ice cores, and they cut take samples here on the place, but basically nowadays ice cores are taken to the country mainland and then measured in laboratories, not in the field, only some analysis on the field there. And well, what was outcomes of Epica? It was really one of the biggest contribution to global climate change science and actually really physical basis, what we got. And also gases, how the gas concentration has changed in different climatic conditions. And also a lot of information how the actually climate changed, how they coupled between northern hemisphere and southern hemisphere. This is so-called peculiar coupling, and actually this is connected through the ocean conveyor, which is actually delivering energy, and so it connects northern and southern areas. And of course, new tracers came into place also, noble gases for dating, which is nowadays actually, it has been all the time very difficult how to date ice cores. They were modeling, radiocarbon is going only up to, let's say, 45,000, 50,000 years ago, but were interesting much longer time scale. So noble gases came to the place nowadays. And yes, this is which this EPICA community is very proud. They got even EU largest prizes for that, because it is just a show of very good cooperation between the countries and how we can achieve something very important if you put our efforts together. And a lot of scientific papers, but of course just a lot of basic knowledge, very important knowledge how the climate system is working. And yes, I go a little bit further. Yeah, not to forget that I also told that we had ice core studies also here in Estonia. We started in middle 70s, and in this time mainly we worked together with our Russian colleagues. Moscow Geographical Institute had the glaciological expedition on Svalbard, and they provided logistic and we provided laboratory, because in this time, during Soviet time, we were only laboratory working with isotope geochemistry of ice core. So also in Severna Zemlya, and also in later on in 90s, we started to cooperate with our Norwegian colleagues on Svalbard. Also the same basis, they provided logistic, and we provided our laboratory competences and experiences. So yes, there are just marked some places on, of course, on Arctic, there are smaller glaciers, so the time scales are not very long, several hundred years, but actually we got information about how the environmental, how the contamination from the mainland is actually reaching the Arctic, and also, of course, a little bit still on the climate history as well. In '79, we were drilling together with Russian colleagues on Severna Zemlya. It is just now a picture to show how primitive in this time was drilling, if to compare which I showed nowadays in Antarctica. But basically this worked, and actually our Russian colleagues tested the drills to go to Antarctica here. And so we got the samples and actually got very interesting results. And this is our only, let's say, not only, yes, there have been actually more as well, but actually, let's say, basic contact with drilling in Antarctica on Dome B, which is station upstream from Vostok Station. And in '87, Russian colleagues were drilling there, and one colleague from our lab also participated in this drilling. And later on, we measured isotope composition. In this time, we were able to measure only oxygen isotopes, but then we worked together with our French colleagues who measured deuterium also. And then published several papers which are very well actually cited up to nowadays. So this was our contribution to Antarctic research. And then after the EPICA finished successfully, then ice core scientists organized such kind of EPICS, which is International Partnership in Ice Core Sciences. This is grassroots actually cooperation, people working on ice core and discussing on what planning next ice core, what should be done, where to drill, what is important, what questions should be actually solved. And Estonia, as you see here, is also included here on this discussion. And one of the major, actually this community produced several white papers, actually putting scale, in what places and what study would be done in further. And one of the major questions was that if basically the basic idea how climate is changing about the Milankovitch theory is known. And there are, of course, several how ice ages during Quaternary have changed. And not only ice core, but only ocean sediment showed that if up to the Middle Pleistocene, up to, let's say, approximately 1 million years ago, the ice ages actually changed with cycles of 40,000, 41,000 years. But from this point, it started to change much with much longer time scale, with 100,000 years. And there was no idea what happened because Earth's orbit actually, or the sun is not changed. There has to be something else. And now then ice core community concentrated to find a place where to drill ice core more than 1 million years. And actually now, just those days, this work is going on. It started 7 years ago. Of course, COVID situation a little bit influenced also on this endeavor, but our last meeting, people showed that most probably during next year, they will reach the bottom layers, and we get the information about the climate change during the 1 million years, and maybe then we can also solve the problem why this big change in Middle Pleistocene happened. So, and I would end with this and saying that even if Estonia is not rich enough to put a lot of money on this kind of research, which is important research, but I think that the most important thing which we have actually get is that actually we have this knowledge, what we can get from ice core. We are actually recognized in this community, and I guess in future, our younger, because this is now also included our university curriculums, the students know how to get climate information from ice cores, and in future, at least, we will have people who can actually help our politicians to make decisions about how to act with climate policy, and our scientists have actually strong base how to explain this, what has happened and what will happen in future. So I guess this field of research will continue in Estonia. Thank you very much.
Thanks a lot for an overview of this amazing world of archives back to 1 million years. The next 8 minutes will be the most boring of today's Science Afternoon, because this is about bureaucracy in some sense. It's about Estonian Academy of Sciences Arctic research professorships. The positions of research professors at the Academy were actually established already in 2002. They were designed for scientists who are internationally recognized in their field, and also who would be available, at least for some time, to focus on a specific topic. It could be either mainstream, it could also be a niche topic, and they also were supposed to strongly contribute into supervision of young researchers on this particular topic. The requirements for candidates for these research professors were actually, I would say, very harsh. It was requested that they have at least 10 years of experience at senior scientist level or university professor level, plus demonstrated success in supervising of PhD students. There are just a few hundreds of persons in Estonia who have this kind of expertise. So for more than 20 years, research professors of Academy have been individually selected from this pool of esteemed scientists. And this was done based on their own preferred research topic. The Academy assessed the candidates' qualification and research program but did not intervene in the selection of topics. And these positions were financed directly by Estonian Ministry of Education and Research. So this approach has allowed by now already for almost 25 scientists to work on a set of problems what they have chosen themselves. To some extent, forgetting about bureaucracy as much as it was possible. And many cycles of this kind of work have received National Science Awards. And also about 1/2 of research professors have been elected into Academy of Sciences. About a decade ago, the Academy found that it would possibly make sense to apply this practice to topics and tasks which do not really stem from scientists' own thoughts, but what stem from the needs of state or society. So the idea was very simple, that we should possibly motivate and inspire top-level scientists to focus on such tasks that are of strategic importance, not only for the development of science, but also for society and needs of country. And we had in mind specific areas for which financing from other sources might be difficult. And this kind of idea, it seemed to have a good potential to fill existing gaps in our research landscape, which is not very large, below 4,000 scientists altogether in the country. And it would also encourage some scientists to specialize in prospective areas that are still in the phase of development. And this approach to our understanding had a much more general meaning. If we really want to take a place among the richest countries in the world, then we need to engage cutting-edge science to solve these tasks which are faced by state and society in general. And more generally, we actually have to do something to shorten the time from obtaining scientific results to their actual utilization. You may call it innovation. And this idea was brought into life thanks to additional funds allocated to ministries in the framework of the National Agreement on Research Funding concluded in 2018, the point of which was increase in science funding to the level of 1% of GDP. So our thought was that extending the corps of academic research professors to the scope of different ministries, it would be a nice way to engage the best academic competence in solving matters that are important from the state's perspective. And this framework, we thought, would also make possible to direct the state's needs into the research system very rapidly, and on the other hand, to bring top-level scientists closer to actually serving society. Those words have been mostly understood as buzzwords. So the relevant new statutes for research professors entered into force just slightly more than 1 year ago in spring 2022. The change of the rules is that now predefined topics or research fields are in the system, while the requirements for the candidates are equally harsh. The only difference is that now poor research scientists may apply who have not yet supervised PhD students. So this opens the gateway for those who are working in autonomous research institutions or in private, or even in private sector, and who are not teaching in universities. The Academy, as before, offers its experience in finding the best candidates for such research, and also to some extent motivating them and inspiring the best persons in the field to apply, and also some sense will provide the service of looking at the outcome of the results and telling to the state whether the professorship has been successful or not. The Ministry of Foreign Affairs is the first ministry in Estonia who decided to channel part of its research funds into academy research professors. This process started last year when a competition was organized for 2 research professors who were focusing on Arctic studies. Of course, there is a lot of philosophy behind, but we think that international cooperation of Estonian researchers in the Arctic is really important, because if we look at things what happen on our planet today, the key for understanding lies in the highest latitudes close to the poles. If we do not look into those regions, we are like half blind in interpreting what happens to the planet. A specific feature of this particular call, which was suggested by the Ministry of Foreign Affairs, was that the elected professors were expected to create small research groups by engaging at least 2 additional contributors. So the idea was actually very simple. Financing a single person for a short time doesn't make much sense. He or she does something and returns to his or her own field. But this kind of nucleus of research work would possibly be made sustainable through follow-up financing. So in the first call, 5 eminent scientists submitted their applications. 2 were selected, which is extremely high winning rate in Estonian system, 40%. So one of these selected scientists, Aimar Ventsel, he concentrated on studies of representative organizations of the indigenous people of the Arctic, and also what those organizations are doing. It might be not really natural science, like Kati Lindström was mentioning, but this is really important to understand what's happening on this landscape. What the role of scientists, or classic scientists, could be in supporting these organizations, what kind of cooperation formats there might exist, and where are there options for Estonia to contribute. The other winning research professor, Lauri Laanisto, focused on the connections between the diversity and productivity of plant communities. So he had contacts with a long-term experiment on Spitsbergen, and we understand that, so to say, thanks to particular rapid climate change, this region has become one of the best sources of knowledge about the impact of these changes. The both selected professors and their groups planned extensive field studies, of course, of very different character, one in social sciences, other in classic natural sciences. While plant community studies were, of course, doable, and they are still continuing, the analysis of representative organizations of indigenous people was severely hindered because of Russian aggression against Ukraine, and this made visits to Russia just impossible. So Professor Ventsel had to work with Russian immigrants in this direction, which is, of course, just a reflection of things what happen. So The second call for research professorship focusing on Arctic studies was issued this spring. The scientists who won the professorship last year were, of course, eligible to apply for a follow-up. And this time, 9 scientists applied, which in terms of 2 winning renders the typical winning rate between 20 and 25%, which is standard nowadays in Estonia. So Lauri Laanisto received a follow-up support to continue his studies on connections between the diversity and productivity of plant communities. And the new group of Heikki Junninen focuses on the properties and role of aerosol particles in the Arctic region, with specific attention on bioaerosols, such as pollen of plants, which is a very important source in terms of history, or germs or spores or germ of fungi. And these things are really crucial in understanding of how these species colonize new areas in the changing conditions. So if I now try to draw a kind of conclusion, it seems that the framework of research professors of this type seems to be launched successfully and has already shown quite a large number of interesting outputs. And we hope very much that it is possible to increase the duration of such professorships. They are now just 1 year because of formal reasons. We would like to see them at least 3 years duration. This is time which is usually needed for successful team building and reaching at least a little bit research sustainability in the new direction. Thank you very much for your patience to listen to this bureaucratic information, and I hope very much that other ministries will follow the example of Ministry of Foreign Affairs. And now comes something much more inspiring. It's about possible application of biorobotics in Antarctica. Our good colleague, Academy member Maarja Kruusmaa from Tallinn University of Technology. Welcome.
Thank you very much. Thank you very much, and good afternoon to everybody. As the introduction already said, and the name of the university is becoming a University of Technology, and what I'm doing is technology. So basically, I'm doing all sort of sensing technology, or in other words, my specialty is taking my technology in very obscure places. And one of the most obscure places that you can think of is already, of course, like sea and ice, and in the best case, something in between them, or as we call it, ice and sea interface. So we started about 5 years ago to understanding glacier hydrodynamics. We all know that glaciers are melting. They're melting with too fast rate, but actually they always be melting, and they're melting all the time. Because in summers, there are temperatures above 0, since the water is melting on the surface of the glacier, and all this meltwater goes somewhere. So normally it makes like holes inside of the glacier, which is called moulins, and the water just drops into them. But then we actually don't know what happens to this water. It just goes somewhere, but you know, if you have just short glimpses into the glaciers, then you can imagine something which is like a giant water park, water slides, you know, with ferocious velocities of water going through it. But you don't know what's happening it. You just know it at the end, it's coming up somewhere under the glacier, and it's called a glacial outlet. If it's a marine terminating glacier, that it's somewhere, you know, in a thick mud. And if it's a land terminating glacier, and if it's a marine terminating glacier, then it goes out somewhere into the ocean. And in order to understand the glacial dynamics means that if we want to know how the glaciers moves, so we actually should understand what is going on inside of the glacier, which is one of the world's most inaccessible environments you could ever happen. So my idea was very simple 5 years ago. I thought that I have these very, very nice sensors which are very rugged, and if I just drop them into the glacier and I catch them out from the other end and I record all the data, then I will have it. Well, like fast forward 5 years, and we were still doing all those things, having things in the glacier. It's very nice when you look at it on the surface of the glacier because you have a GPS signal and you can exactly record how this thing is going. But once it goes inside of the glacier, you lose all the communication, so you don't actually know what has happened and how it's coming up from there. And so fast forward 5 summers, we've been dropping our stuff into all sort of things. And sometimes we find some and sometimes we don't find some. So it's, you know, the most frustrating and the most funny part as well with, that's me, with the Arctic field work, like going miles and miles in the mud and seeing if you can see something which is green or yellow and resembles your lost equipment. But that's actually just the beginning of it, and you end up with a chunk of data, and the data is showing you the velocities of the water, the pressure, and also inertial measurements. It means that it shows you how the things that you dropped into there is moving inside of it. To understand that, then I hired a mathematician, and she was working for 2 years, and after 2 years she was actually able to say or construct the topology of the channel inside it. So later we could see that once we managed to catch this glacier, we could actually construct the whole path, how the thing is moving inside of the glacier, how fast it is moving, what kind of pressure are there. The pressures are particularly interesting because sometimes when you have a lot of meltwater, suppose you have a extraordinary hot summer, as we have had on Svalbard and also Antarctica in last summers, so we have a lot of meltwater. And all this meltwater goes inside of the glacier, like huge amounts. And so the pressure is increasing inside of the glacier. And sometimes the pressure is so high that it's basically just lifting up the whole glacier from the glacier bed, you know, tons and tons of ice. So what happens after that is kind of, there could be just accidents in places where also people live, like Himalayas of Greenland. So, you know, the glacier is in one place one day and a week later is in the other place. So there's kind of, you know, incidents which are very hard to model and predict what is happening. And we try to also kind of catch a glimpse of that. Besides that, since we are very good at building technology and then losing the technology, we started another field experiment a couple of years ago in Svalbard, and it's, I think it's officially the first Estonian finance field campaign of a polar field campaign, at least during the independent Estonia. I'm not talking about your reign because, but it was before that time right now, you know, and we had a project in Svalbard to understand the climate change or the effects of the climate change to the local glaciated fjords, how the ecosystem and currents and sediment transportation is affected by the climate change. Svalbard is an interesting place in terms of when it comes to climate change because the average increase in temperature on Svalbard is much higher than in the rest of the planet. So you can think of it as a kind of a laboratory of a climate change. And when it comes to polar research, so polar research is very difficult. It's very expensive and everything, but Svalbard is fairly accessible place and fairly well supported in terms of logistic transportation and infrastructure. So, you know, when you're already going to hard places, difficult places, it's a good place to start with Svalbard for exactly that reason. And also it's kind of, you know, there are kind of a models, it's kind of a model of the rest of the polar regions, like fjords are small, relatively small, glaciers are small, relatively small, and the changes are much faster, so, you know, you have more hope to actually just catch those changes and models them. And what we did was that we investigated the coastal region of Adventfjorden, which is a fjord in front of the only permanent settlement in Svalbard, Longyearbyen. You maybe, Rain knows, when you went to Svalbard, since this fjord was under ice year-round. And one of your colleagues had actually sent me a picture from 1980s where he was crossing the fjord with dog sledges. You can't do it anymore because it doesn't freeze anymore. So from 1980s to now, the changes have actually been that fast. And the same is here, so it like just partially freezes nowadays. And a year ago, we put our sensors into the Adventfjord and of different places to understand how the currents move and how waves move and how sediment forms. And then that is now taken 2 years ago. You can tell a difference between a sensor that is just put on a seabed and the sensors that is taken out a year later. And the recovery rate was quite good, so we managed to recover 6 sensors out of 9. We're pretty happy with that. Yes. So how does it relate to Antarctica? Only in a way, as I said, Svalbard is kind of a model of a bigger landscape, polar landscape. In Antarctica, everything is huge, like huge, huge, huge. That also comes to technology, that also comes to people. You have to go there with a very reliable technology. You have to go with big ships, with big ice shapers, with very well prepared crews to very, very remote places. And you could see it everywhere in polar research now internationally, that it's kind of consolidating. If you want to do polar research, and you actually have to team up with Americans, team up with Canadians, team up with French. I'm teaming up with the Norwegians for 5 years already, because going alone is not really an option. It's not a smart thing to do. It's kind of a field of research that selects out everybody who's not good at teamwork. So sooner or later you're out from there. You're not invited back anymore. So it kind of works so that people who've been working, on the other hand, in polar research for 20 years or more are extremely nice people, because, you know, they kind of filter it in on the other way. Well, my first attempt to go to Antarctica was with a third catchet. You could see there's a blue one, and it's actually, I'm gonna send it next week to Stockholm, and it's a Swedish polar researcher, Anna Wåhlin, is going to take this little catchet and put it on a big robot called Hugin. It's a Norwegian robot manufactured by Kongsberg that goes very fast and very far and very deep. And she will send it under an ice shelf in Antarctica. And this little sensor is recording turbulence and water currents. So she would understand how the water is rotating under the ice shield to get an extra information about what kind of currents are influencing the melting rates of the ice shields. So exciting times are coming. I hope to come one day together with my sensors, not this time, but maybe next day. Thank you.
Thanks a lot, Maarja. I hope you will stay until the snacks will be available. So then people.
If there are snacks available, then I will definitely stay.
Oh, then I reveal the secret.
Thank you.
But now I have the pleasure to invite here 4 out of speakers to be the target of different questions. Dr. Ivan Blum, Professor Rein Vaikmäe, Dr. Kati Lindström, and honorable guest Andres Tarand. Yes, Andres Tarand has to set up the microphone, so, but you're welcome to take place here. It's called roundtable discussion. It's not really round, it's a little bit rounded thing here in a whatever sequence you like to. Andres will join us in a few minutes. So, first of all, yes, you now know each other. Yeah, no problems. I can just, I mean, he is, as former prime minister, he has the ability to react to any situation promptly, so it's not a problem. I haven't really warned the panelists what will happen next. I think you are all so experienced panelists that you probably knew before coming here that the panel will have a classic structure. First, 3-4 minutes introduction from all of you. 3-4 minutes is just a time scale, not the exact measure. Your reflection of what you heard or something what you would like to add to your presentations. Then I shall torture you with some questions. And then after that, you are prepared to the questions from audience. At the very end, I know more or less when then will come, it's about 16:15 or 16:20, then it would be really great to hear a take-home message about 1 minute from each of you. This message is typically the most important because what you have told here is already now forgotten. But the take-home message from the panelists at the very end is what is really being taken home. So after this very short preparation time, I would call first Dr. Evan Bloom to reflect on what you have heard today or what you would like to discuss now.
So thank you very much. So my reflection is that clearly what we hear is how polar science is an international endeavor. And so even if there are certain projects that may have a great connection to Estonia to a greater or lesser degree, all of the type of work that we have been hearing about, whether it is review of historic sites and monuments or ice cores or application of technology, is being done collaboratively at the poles. And so from my point of view as a diplomat, I'm not a scientist, so I always enjoy hearing from the scientists and what they're doing, whether I understand all of it or not. I mean, that is a different sort of question. But for the diplomats, the objective is to how to facilitate the work that they are doing. And part of that has to do with making sure that governance mechanisms and contacts between governments are working well. But part of it is making sure that there's adequate funding. And part of it's ensuring that the collaborations among key friendly nations are kind of all working together in the right way. So all of these, what we've heard today, are great examples of this work. And I think any Antarctic or Arctic scientist would kind of appreciate, yeah, this is great. This is part of the greater scientific effort and worth supporting.
Thank you. In which sequence we should go? Now we ask advice from the audience. Who should be the next? Point anybody. Okay, Kati Lindström, please.
Okay.
Your reflection.
Yeah, well, that was, I am a bit unprepared for that. Maybe not as experienced as my estimated colleagues. but I come from history. So what I do is, how I got into Antarctic affairs is that I actually speak most of the languages that are necessary for studying Antarctic treaty history, including Japanese. So I've been to these very obscure archives and sat and looked at how Antarctica looks from different states' perspective, including the countries that are not often mentioned, that are not the big players. And then I've also sat in the archives of environmental activist organizations like Greenpeace and looked at how Antarctica looks from their perspective. And I think the worry for the Antarctic treaty system right now is sincere, in the sense of that we've been talking about the Russian obstruction of a system, also Russian obstruction of research and of projects not happening. And an Antarctic treaty system has had difficult moments before. It's South African apartheid, there is Falklands War, and there are difficult moments before. But this one is a particularly difficult one, and I think one of the big worries is not only just the Russian aggression towards Ukraine, but it's also Chinese obstruction of precautionary principle. Because when we look at the historical examples of crises, everybody cared about the survival of the Antarctic treaty system. So even the conflicting parties, they would want the treaty to go on. Whereas today, I'm not so sure if all the parties actually care about the treaty continuing in its present form. And that is a big worry. So, and when I've been looking at these big archives, I've always thought to myself, so what is that a small country can do in this big system? I mean, we were part of a big system and could do science in Antarctica. We can do some science today when we team up with the big players, but what can we do in the treaty system? And I've been to the consultative meeting just once, and obviously there's very limited amount of things that we can do there, but what we can do is to take part in the Committee of Environmental Protection, where the voting system is different, and even small countries can take roles in their fields of expertise and play an active role in that the rules-based order in environmental protection would actually prevail. So this is probably one of the few alleys where Estonia can actually still kind of be great again. Thank you.
Okay, thank you. Now we have choice just between two persons. That's much easier. Before we had three. Any choice? Then I shall make choice. Andres.
So I am sorry, but my devices are now double, and I cannot hear very much.
Call it artificial intelligence.
So,
but your reflection, what you would like to say after listening the talks.
Yeah. But
whatever you think is important.
No, my Antarctic expeditions were so long ago that I have not very young notions of that. So.
But still, you are the person.
I was second time only 4 years ago, but then I was very much sick.
Oh.
So it was interesting, but not very much new. Antarctic, however, this tourism and they were for me absolutely new things, and I was there one tool to take some my knowledge is what I knew about this, but this tourism is very much controlled nowadays, and you cannot make a step to the penguins, toward to penguins, because it is not allowed to do. But if they come to you, it is okay.
So just continuing with you for a second, you're probably from this audience, you have survived the most harsh conditions, minus 50 degrees, etc., in Antarctic. What would you recommend to those who are now studying at Antarctic? Should they go there to the site, or should they use only remote sensing and devices which are left over winter there? Should they have sort of hands-on action in Antarctic, or are devices already okay?
Who? I couldn't listen now.
The point is that we do have now a lot of devices left in Antarctic over winter. Do we still need people to be there over winter?
Yeah, it happens. I think there are, how many states had this Antarctic treaty? Yeah. 30 more.
30 plus, yes.
Mm-hmm. So they are overwintering there all.
It's still necessary.
Yeah, but the Finnish and the Swedish, they made a shorter time, and they can make their work well.
Yes. So this is the eternal problem, not actually eternal problem. If we want to know more about our world, I think Maarja has already told that we have to go to places where there are no measurements available. If we measure in places where we have long time series, it's nice to do, it's good to have, but we need badly information from places where there has been no measurements until now. Otherwise, we can't really advance our understanding of things. So, Rein, you have now left last in the sequence to express your opinion and reflect on the matter.
Okay. One actually what was taken actually went through several presentation areas on Antarctic Treaty. My understanding is that whatever the treaties are, scientists who are working on Arctic or Antarctic, they don't care what are the treaties. They are keen to do their research, not pay attention if there are some official treaties. Of course, they know the rules, and by my mind, what Maarja told, the main rule is you have to be cooperative if you are working in polar areas. And of course, to take care to take seriously problems of environment, not to pollute, all these things are so normal. But those treaties, like Antarctic Treaty and other treaties, also Svalbard Treaty, which Estonia is still part of it, because Estonia joined the Svalbard Treaty in middle 20s, and we're a member of the Svalbard Treaty up to now. But this is more political level. And as scientists, we cannot say that this is not important, because which treaties the countries are signing, it shows what are the values in this country. And it's quite understandable that in the early 90s, Estonia regaining independence, we tried to be part of every international body, UN, whatever, also Antarctic Treaty. Estonia joined because we have long history in polar research, especially in Antarctica also, and we joined Antarctic Treaty. But then also we took obligatory side problem. We also promised to join Antarctic Environmental Protocol. And this has been actually during recent years quite a complicated topic, because in the 90s, our polar community, we were actually very enthusiastic that we will establish our Estonian Antarctic Research Station in Antarctica. And this there were many enthusiasts, and there were times when even government partly supported this idea, universities were behind that part. When we were looking on the, let's say, resources, but we have human resources, but especially also research money, then quite quickly we understood that actually just to put money on infrastructure in Antarctica, this is maybe not the most clever idea. Maybe just support scientists to work in cooperation with other colleagues like it has been earlier, and just forget, because to have our flags there, you can put our flag also in other station if you are working there, but just to build a station, put a lot of money on that, it would be, I guess this idea was okay, but we were pragmatic, and we decided not to go on that. But to sign environmental protocol is still important, because with this, our state will show that we take care of what is happening in Antarctica, and if we don't have our station, there all the bureaucracy behind that, all the reports, this is not so difficult. If you have a station, of course, you have to report every year what you are doing, how to care, and this is a big job. But working with other stations, then this is a problem with their station, and you will just behave like a normal scientist, and this is not big obligatory for the government. But to sign the protocol, it shows our values that we support this kind of ideas. And as I have understood, it has been several times in the government. Government has decided, yes, we will sign Madrid Protocol, but finally still the fear that there will be financial obligations, it has stopped all the time, and we can understand if we see recent days how the government is discussing the next year budget, how difficult this is, and how every field, actually social fair, education, everything is actually demanding money, and if we now go with problems that we have to sign Madrid Protocol, I understand that the financial ministry will be actually very suspicious. For sure you will need money, but we can assure that this is not maybe, this is actually, let's say, resources for one person to write reports during a year what Estonians have done, and actually the community is so small, and I guess this scientist himself or herself can actually help to do such kind of reports, but my understanding is that signing the protocol, with this Estonia would show to the world that how we take care of the environment, not only what we have in every day here at home, but basically we think globally, and this is just a sign for the government. This is actually my understanding, and I really hope that once will come the days before we with Anders leave the place for the younger people, that government still will decide that Estonia will join Madrid Protocol. This is my message.
Yes, this is a variation of the question what was before, Heeg or hen or egg. And a good strategy for scientists is to show his or her results first. So this has happened in Estonia in terms of polar research. It's just probably you have already heard some information from Jonne Kotta from Estonian Marine Institute, Tartu University. So he was able to construct a quite decent quantification of resilience of ecosystems. And while you were showing that ice core and situation in Greenland and in Antarctica just mirroring each other, this is not the case in terms of ecosystems. While the Arctic Ocean ecosystem, not counting ice bears, is fairly resilient, the Antarctic water ecosystem is not resilient. It's very fragile. It's much more fragile than the Arctic one. So the poles are not equivalent. In this sense, we do have already results which are, if not shocking, then seriously informing the world about this kind of asymmetry. But now I think it's probably time to pick up some questions from audience, if there are any. The typical way of bureaucrats is leaving just 2 seconds for thinking and then saying there is no questions, we go further with discussion. So please be very rapid. Yes, Renno, please.
Thank you for the opportunity to ask a question. And I guess this question is not specifically to one or the other of the panelists, but more general. So I would ask, what would be the appropriate level of ambition for Estonia? So everyone, or most of us, agree that in some form we should be there, or should be engaged in this research. But what would be the sufficient level of ambition? Is it that we spend 1% of our R&D funds to this research, or would be 5% be something to think about?
I think the external view is probably much better than our internal view.
Well, if you're asking in terms of the metric, I certainly don't know and would hesitate to advise what another country should do. But I guess just building on what I was saying before, there are a wide range of countries, particularly EU, US, I mean, even Canada wants to become a consultative party to the Antarctic Treaty. And I think that in this time where climate change is so important, a wide variety of similarly situated countries have shown that they have a strong will to be part of this scientific endeavor. And it doesn't come cheaply. So it takes a lot of organization, and that means going to finance ministries and scientific academies and others and trying to motivate. So I don't actually have an answer to your question, but I can say that if Estonia decides to invest more in polar science, they are in good company with US, EU, and many similar states.
Thank you. Any additions?
Can I?
No, if you wish.
Yeah, so I wouldn't know about the percentage, but obviously perhaps we're a bit ill-advised to try to copy the US programs because they're just so vast. There is like, this is a different category, but it would already be of help if there was a measure similar to the Arctic Professorship, that there is, most of the small countries like Estonia have been asking around, what do others do? Other midgets, how do they keep themselves alive? And they have normally a joint pot for polar research, Arctic and Antarctic. So people like Maarja can get fly robots to both ends, for example, or satellites. Really doesn't matter so much which pole often you do your work with. So that there is some regularity in the pots of money you can apply to, even if we're not capable of perhaps having a very regular program with guaranteed funding to everybody who wants to go. But just to know that, okay, if I can get myself through the selection process, there will be a possibility to apply again. That would help a lot with educating the next generation of polar researchers, because this research is very resource extensive, as has been said. So you need to have some plan towards future, more than 1 year, some possibilities for application for funding to create this continuity. I take on master students who can do some data analysis. I take on these people to do that work.
Any other?
Tarmo, maybe also to reflect, I would also not say any percent, because basically we know how research is financed in Estonia. We don't have any percentage for physics or mathematics or earth sciences, but I maybe go a little bit back. In 2012, Ministry of Education and Research asked Tallinn University of Technology put together a team of Estonian polar researchers and build up Estonian polar research strategy and plans. We did this document. Polar researchers were actually very enthusiastic. We had many discussions. Of course, at first we tried to find out where are our experiences, where are the best results and what is important in the world at the moment. And so we put together, let's say, dreams program, what it would be important to do in Estonia. And actually this document went through international evaluation. We got quite a lot of critics, and critics was mainly because the foreign experts told that your polar research community is getting too old. You must attract more young people. This was obvious for all of us. And actually this document was, because this was ordered by Ministry of Education and Research, but this was, let's say, more or less climate problems, and so this was handed over to the Ministry of Environmental Ministry. Nowadays it's Climate Ministry. And there it stands up to now. There is nothing. We even made some calculation what kind of resources should be behind that we can continue our research. My idea is maybe not to say now what should be the percentage of money dedicated to polar research, but to, let's say, modernize this strategy, to take account what has happened in the world and in Estonia, because actually generations have changed, newcomers are there, where are our strong fields, and actually to put together a new strategy and actually to build Estonian polar research strategy, and then discuss how much money a state could actually dedicate to that. Because not just this is only not the polar research itself, there is now many other fields which are included also there, because this is a multidisciplinary area. But start actually from building a state program and then to discuss and to see what our government actually can dedicate to this field. This is my proposal.
Yeah, okay, thank you. Yes, please. But please have a microphone just for having the question recorded.
I simply want to say, no matter do we have the strategy or not, I'm very happy that our polar researchers are so active. It shows the will to do and what they have done through the last 40 years. But of course we need archaeologists, to what Rain mentioned, to find out this very good document and to put in the new changes. Because I am in contact with the young people who study now in our universities and abroad. And they are looking very carefully what we are doing here in Estonia and they are eager to continue. What I would also thank Ministry of Foreign Affairs, because one update actually was done when we started this campaign and cooperation towards the Arctic Council, where we dreamed to be the associated member. Then somehow there was such a moment of activeness that the people from different universities, institutes, we tried to put the input. So let us hope the best. Now we have the new ministry. At least I hope. Thank you.
Yes, that wasn't a question, but still, thank you very much. The process of obtaining observer status in Arctic Council led also to preparation of the action plan for Arctic. I'm not sure whether it has been finally approved, but it is quite substantial. And I think that for a small country, it's important to move relatively small steps. I understand you can't cross a big chasm with small steps, but we should avoid facing big chasm. I do have my own questions to every participant here. I can start from Dr. Ivan Blum. We are mostly scientists here, and we're really interested on your view, which is the most burning scientific issue of polar research globally, to your view? And the accompanying question is, which one would be, which topic would be where Estonia could at most contribute? Just your personal opinion.
So, as a non-scientist, that's very hard for me.
That's
to
why I'm
answer,
asking.
But that's why you asked. So, fair enough. Fair enough. I think that these days, anything which touches upon the fundamentals of climate change is something that is important for the international community and well worth thinking about. I'd also like to mention, it's only come up briefly here, the effort to work on marine conservation issues. So coming back to Antarctica again, we had in 2016 the Ross Sea Marine Protected Area was created, the world's largest marine protected area, and still is the world's largest marine protected area. But since that time, our Russian and Chinese friends have decided that this is not the direction they want to go, and has made it difficult to make progress. And yet, it's a very important area because marine conservation is increasingly important to the world community. It's connected to the Convention on Biodiversity's objective of protecting 30% of the planet by 2030. And in order to achieve those sort of goals, you really have to make progress in the Southern Ocean, in Antarctica. So, and part of the reason that you need that is not just to protect biodiversity, but to do increased marine science. And that, I think those things are connected. So being able to participate in marine science, whether it's on one's own ships or not, a lot of these things are being done remotely and with remote sensing and from space, and there are all sorts of steps, but that's another interesting area. Thank you. Then I took next Kati. So already I think it was Dunn who told that no man is an island. So Antarctic is not simply an island. And we know from Ernest Hemingway that the loss of a human person is loss to everybody. So I have actually a double question. So what we can really lose in terms of cultural heritage if we ignore the processes in Antarctic? And the
sort of accompanying question is there is no indigenous people in Antarctic, not known. I mean, the seal hunters 200 years ago, they can't be counted as indigenous. Who should be the owner of heritage in Antarctic?
It's a very complicated question. I mean, obviously we can say the world is definitely going to lose much more important things than Antarctic heritage if climate change continues, and particularly if it continues with the high-risk scenarios. Most of Antarctic heritage was essentially throwaway items, right? This was people who went down there, and it's like, you know, these plastic cups you would have today. It's basically, well, this is a wooden house, we just leave it here. Dogs were also one-time use items. You would just eat them up when you come home and throw the bones around. So, I mean, most of Antarctic heritage is waste to start with. But that said, it has a very important, for one, we lose knowledge, obviously, particularly when it comes to sealers, because they managed to hunt the seals close to extinction. And they've bounced back to a way, so there is a lot of knowledge that is lost. Obviously, most of it will not be able to be preserved in its physical form. So what, I mean, no matter how much we try, I mean, we're optimists thinking that the snow hill house will perhaps stand 30, 50 years, but I don't think so. Looking at the speed of the processes, it can dissipate earlier. So there will be a question for the governments to decide what they want to do. So now, heritage system in Antarctic Treaty, it's a very complicated one. So officially it has to be of interest to more than one country, the global community. We have quite late definition of the values that these places should have, a scientific value or historic value of a major feat and so on and so forth. Originally, the list was composed without any explanations. Any government who's interested in protecting something just say what they want to protect. And that was really a measure to make sure that no Antarctic Treaty country would erase the historical sites and monuments of the other countries, and that they don't get looted. So it has an important role, I think, in for the stability of the Antarctic Treaty system. Because when the territorial claims to Antarctica are frozen, they're still frozen, and these heritage sites, they function as proxies, and that makes people feel safe about possible futures.
So mostly this protection is passive, not removing. It seems that this is not enough. By simple reason, the Arctic and Antarctic coasts, they are not only being eroded, they are melting. That's why the coastal recession is by 1 or 2 orders of magnitude faster than on our latitudes. But you mentioned the waste. You know, by far the largest source of archaeological information comes from waste. Yeah. And you know, from the science philosopher Murphy, errors of one person is a input for science of other persons. So I'm very positive in this sense that a more effective solution will be worked out for Antarctica as well. And as we learned just a few weeks ago, people who are wintering in Antarctic, they are already developing their own language, their own dialect, their own pronunciation of words. So Antarctic is becoming part of global community, even though there are no indigenous people. Then I have a very short question to Rein. When we talk to finance people and those who finance science and those people who count using Excel the expenses and income, could you very shortly formulate a couple of benefits which Estonia will have from joining the Madrid Protocol? Very shortly, a few benefits what could be communicated to society.
difficult to say, but
Yes, it is.
Yeah. But I think this is more just to show outside that Estonia is taking obligatory seriously. If you are a member of a club, let's say like Antarctic Treaty, then you have to follow the rules, and one of the rules is also you have to remember also of this Madrid Protocol. And this is, on political level, I think this is not only, let's say, a scientist that can say, well, this is not a matter for me. I can work without this protocol, but for my country, I would like to show that our country is taken seriously. And I can say that I represent Estonia in European Polar Board. And this is a company where are actually people, there are quite a lot of scientists, but mainly there are, let's say, science bureaucrats, and there are politicians even. And whenever, when Estonia joined European Polar Board, this was actually taken very seriously, and we are actually the only Baltic country who are actually a member of European Polar Board. And when they heard that Estonia is applying for observer status in Arctic Council, they were very happy and showed that you are taking things so seriously. So I guess that there are some things which are important also on this level, that how the other countries are looking on your country, how serious you are. You can do good science, this is of course very important. But also on this level, like agreements and the countries taking those things seriously. I guess this is maybe the most important thing.
Yes, indeed. Reputation can't be put into monetary terms, but without reputation, you can't run the country on international level. So I'm very thankful for the comments so far, and now I would like to ask the panelists just to prepare a few sentences as a take-home message from you. So, Andres, can you have 1 minute what people should take home from this conference? 1 minut, mida inimesed võiksid koju kaasa võtta sellest konverentsist?
No 1 minute. It means that I think so that our younger generation should be informed, and as much as I know, our Polar Club is active on this. So we are a small country, but these international contacts, which are in very low temperatures, however, but they are important. And so 1 minute.
Thank you. Thank you. Important message. Rein, please.
Yeah, maybe one message, short message is just that I hope that in spite most of our polar research community is rather aged and going to retire, that the younger generation comes, and actually that totally in public also should understand that polar research gives the information which is important, scientifically based, and not to be in the positions that, let's say, one of our previous prime ministers came back to Brussels in climate discussions and came back and told that Estonia is on the position we have to stop global change. So if he would speak with scientists earlier, maybe he would have a better message. So my message is that polar research is important to get information how the Earth is functioning and how we should behave in future to keep in for future generations.
Thank you. Kati, please.
I will continue from where Rein stopped and also following up on the previous one. So what do we get from joining the Antarctic Treaty? Antarctica looks very, very far away from here, and it is. for anyone who has traveled. On the other hand, global climate change in Antarctica will not stay in Antarctica, and it will impact every single corner of the world in a very drastic manner. So if we're looking at the varieties of the sea level rise because of the melting Antarctic ice, they obviously vary largely because there's so many uncertainties about modeling in Antarctica, but we're still looking at the worst case scenarios of 7 meters by 2300. That's like, yeah, well, look how many places in Estonia will be out of water by then. Also, Southern Ocean is 10% of world ocean, and it's crucial for all water circulations in all world oceans, which means that if the southern vortex collapses, which it's slowing down, if it collapses, there's no fish. Like, just as simple as that. So it is very important for Estonia what happens in Antarctica, and there is only very limited ways for us to influence that other than obviously changing our CO2 emissions. One of them is to do good science and to inform policymakers of what is going on, and the other is to try to our own little way to take part in that policy making, and that is only possible through the Committee of Environmental Protection to the Antarctic Treaty. So we hope the Foreign Ministry here hears that.
Okay, thank you very much. And now Dr. Bloom.
So, first of all, thank you very much for holding this event and for inviting me here. It's been a very special time. I've been here for 3 days, and I am truly impressed with the level of interest that I found in polar research and polar policy here in Estonia. It's really quite extraordinary. And it's just great to see it. So, my final point is similar to those made by others on this panel, which is that in terms of Antarctic environmental protection, all key countries who are at the forefront of activity in Antarctica are parties to the environmental protocol. So I would think that it's something that would be high enough up the scale of policy interest within Estonia for that to be seriously considered for some of the reasons that have just been mentioned. So if Estonia wants to lead in this area, I think that's one way it could consider doing so.
Thank you. Just to the very end, I would like to remind one of the most famous errors of Albert Einstein. When he was looking at his equations and trying to find out solution for gravitational waves, at first glimpse he seemed to prove that there is no this kind of solution. Of course, he was wrong, we know that. Gravitational waves have been discovered, and Nobel Prize has been given for this discovery. But if I am very slightly over-exaggerating, oversimplifying the error of Albert Einstein that time, he was not able to properly handle the poles. The poles are nothing specific. They are a problem for our mathematical description of planet Earth. So when he was able to properly handle the poles, the solutions of gravitational waves was appearing. So the message is never ignore the poles. Thank you very much, and follow-up discussion will be in the neighboring room.